Okay, so what we're doing here in trigonometry is we are going to start chapter 2, and with chapter 2, this is section 2.1, and this is degrees and radians. Okay, so we learned that an angle measure of 1 degree is an arc 1/360th of the circumference of a circle. Okay, that's what we learned in chapter 1. Now we're going to learn about another measure today other than degrees. We're going to talk about radian measure. And so radian measure. And so basically what this says is that if we have a circle, okay, and here's the center of our circle, this is our radius, and let's suppose we're going to look at this arc right here. Okay, we're going to look at this arc. We're going to call this arc S, and this is the angle that's subtended by that arc. Okay, we're going to call that theta. Then to find the radian measure, we say that theta equals S over R radians. So obviously S and R need to be in the same units. S is the length of the arc opposite of theta, and R is the radius of a circle. So for instance, if we have if we want to find the radian measure of a central angle that's subtended by an arc that is 32 centimeters and has a radius of 8 centimeters, then we can find the radian measure of theta by saying 32 divided by 8, which of course gives us 4. Now we could abbreviate radians as RAD, but a lot of times what you'll notice in our book and other books is that we will even drop the RAD or the radians. We'll just say 4. If something is in degree form, it will have the degree symbol or the word degrees spelled out. So don't forget that. Now, this would be how we would find the radian measure for theta that's subtended by an arc S. Okay? Now, what about the what about if we know the angle? What is the measure, the radian measure? Let me be more specific. What is the radian measure of 180 degrees? Alright, so 180 degrees. Think about what that is. That's half a circle. So we know that the circumference of a whole circle is the arc of the whole circle. So if we're looking at half the circle, then our arc is going to be the circumference divided by 2, or 2 pi r divided by 2. So for a 180 degree measure, the arc would be pi r, the arc length. So if we take that and we put it in our formula, here's theta equals S over R. Well, now we have pi r over r, which is pi. So this is going to be an important conversion factor for us. 180 degrees equals pi radians. Commit that to memory. That's going to be our conversion factor from converting to radians and degrees back and forth. Okay? 180 degrees is pi radians. So now, what about 90 degrees? What about 90 degrees? Well, all we have to do is use our conversion factor here. We're wanting to find radians, so let's put the radians on top and 180 degrees on the bottom. Well, 90 goes into 180 two times, so this is pi over 2 radians. So see how we converted that degrees to radians? Pi over 2 radians. Now we have a few special angles, okay, that we want to talk about. And coming up, we'll have something called the unit circle. And we'll describe that in depth a little later. But we like to say that 180 degrees, which is this distance here, okay, 180 degrees, we said was pi radians, okay? We said that 90 degrees, which is this angle here, right? 90 degrees is going to be pi over 2 radians. Now, what would 45 degrees be? Well, notice 180 was pi, 90 was pi over 2, 45 is going to be pi over 4, right? Now, various other angles we can get via our conversion. For instance, we could find out what 30 degrees. We can find out what 30 degrees equals. That's horrible. Let me go to the next page. We can find out what 30 degrees equals very easily. So for instance, 30 degrees times pi over 180. If we're trying to find radians, remember, this would be pi over 6 radians. 60 degrees, doing the same method, would be what? Pi over 3 radians, doing the same method. Now, if 180 degrees is pi, what is 360 degrees? Well, hopefully that makes sense that that's going to be 2 pi. Okay? Now, some of these you're going to need to become familiar with and memorize. I would memorize 30 degrees, 45 degrees, 60, 90, 180, and 360 for now. There'll come a time when I want you to memorize those particular angles all the way around the circle. Okay? The pi over 3s, the pi over 6s, the pi over 4s, all the way around the whole circle. And that will make our unit circle that we'll talk about later on. Alright, so remember, pi over 180, or 180 over pi, depending on what we're converting from, radians to degrees or degrees to radians, will be our conversion factor. So, let's look at this example. So, for example, we have negative 1.5 radians, and we want to find the degrees. So we're going to take negative 1.5. Now, this is in radians, so pi is going to go on the bottom this time. We're searching for degrees, so degrees will go on top. Okay? Just like your conversion factors in chemistry. So multiply that out. Now, you'll get negative 270 over pi. Now, don't just leave it like that. For instance, this problem actually says round it to 4 decimal places. So go ahead and divide it. And when you're using your calculator, folks, I know this on the first quiz, make sure that you round at the end. Use the pi button on the calculator. Do not put 3.14 in for pi unless the problem tells you. So use your pi button, negative 270 divided by pi, and that's going to give you a negative 85.9437 degrees. Okay, so that would be our degrees, converting from radians to degrees. And of course, we've already tried some degrees to radians. Would just be flipping our conversion, right? It would be pi over 180 if we were going from degrees to radians. Now make sure you're very precise with this, okay? Especially when you type it in on Wiley Plus. All right, so this is going from radians to degrees. Well, let's look at one going from, going from radians to degrees. Let's go from degrees to radians. So suppose we have 44 degrees and we want to go to radians. Well, this time pi is going to be on top because we want the units of degrees to cancel each other out. So this is 44 over 180. Well, 4 will go into both of these. 4 goes into 44 11 times. 4 goes into 180 45 times. And so this is a 11 pi over 45. Now, most of the time, folks, they're going to ask you for an exact form, okay? This would be the exact form, okay? This is exact. By leaving the pi in the answer is the exact form. Now, if they ask you for a decimal form, just like the last problem, divide it out and get the decimal form. So if we were looking for rounding to 4 decimal places, this would be 0.7679 radians. And remember that if you leave the RAD off, it still is radians. The only time it will be degrees is if you see the degree symbol. Okay, this is our first video on section 2.1. I hope it's been understandable, and I'll be finishing the next video here pretty soon.